I assume that the last big slide with the Open vSwitch and OpenFlow enabled top of rack switches, you have some experience with this. So the question that I have is how many flow updates per second? I can imagine you see a number of flow updates per second in the aggregate to the Open vSwitches. How many flow table updates per second or flow initiations through the slow path per second do you typically see through the top of rack switches?
So it varies a lot by vendor, right? I mean, typically on the top of rack switch, the bottleneck for flow updates is the CPU or the CPU switching chipset bus.
No, that's the capacity. What I'm talking about is, I'm sorry. Let me sharpen the question.
Sure.
In use, when you deploy these things, what's the demand?
I see. Well, typically we design our solutions to. So let me turn the question around, right? Currently, the flow update rate you have on many of the commercial switches is effectively what's limiting how dynamic your network can be, right? So what you do is you basically adjust the granularity at which you manage flows to the update rates that your switches support, right? And to some extent, the TCAMs that they have. So what this means is, as a baseline, you would start with something like managing flows at a per MAC address granularity, right? Or maybe MAC address per port, which tends to be fairly static, right? That's something you need to update not very often. I think it was said here previously, do an update for every single flow, practically speaking, with today's hardware, we're far from that working, right? It's not feasible. You do things at a coarser granularity.
Yeah, but the point is that you can do it that fine in Open vSwitch, right? You're not granularity limited on a software switch that's sitting in DOM 0. So the question is, how often do you actually have to bump? Because that's effectively, the top of rack switch has now become the second tier of networking. And so the question is, how often do you have to, I see Bob Lance is there, and maybe he has a comment on this. So the question is, how often do you actually have to hit those flow tables, and how much of the control you need can you get just by looking at the software switch and the hypervisor?
So if you have a hypervisor switch, what you typically do is, I mean, in general, right? What you typically do is you have fine granularity at the edge, and then as you move towards the core, you get much coarser, right? Which at the end gives you the same result. So if you have a hypervisor switch, I would push all the ACK-link down to the hypervisor switch and basically just do, like pair of hosts-based forwarding at the top of rack switch. We might be getting too technical here.
Is there a rebuttal from the other side of the room? No.
I think Bob has gone away.
Another question? Go ahead.
I'm curious, with Open vSwitch or other OpenFlow-enabled hypervisor switches and the emerging standard 802.1 QBH, QBG, VEPA, a lot of complexity around how to perform virtual machine hypervisor switching. I think, my perspective, I'm without knowing a lot about it, it seems OpenFlow is a simpler way of accomplishing a lot of the goals that you're trying to accomplish with those. Do you see them as competitive? Do you see them interoperating, and if so, how?
I mean, to me, the different tools to achieve the same goal, and actually in certain situations, some are advantageous over others, right? I mean, we're using a number of them. They all have their strengths and weaknesses, and how much of the networking do you want to do in software? How much of the networking do you want to do in hardware? How much physical hardware do you have? Something like VXLAN is great as a tunneling technology. So, I think they're very complementary.
Thank you.
Yeah.
Any other questions? Thank you, Guido.
Thanks.